a form of classical test theory. So permit me to share my screen. And if I can have this. Can you see my screen?
Yes, we can.
Yes, we
Okay.
Yes, we can.
Okay. This is my hardware environment. So like I said, it will continue from where we stopped, but I've done some other analysis. So then I've lost what we have done earlier. So, but tonight we start from the item response theory, item analysis. So, and we are using the same data. And I believe by now, all the participants must have gotten the data set on intelligent quotients. And then we have about 5 items measuring intelligent quotient of a grade 5 learners. And then the items were administered to about 400 learners. So, and then it was scored dichotomously. We have the 1 and 0. And the item response theory have 2 different models. We have models for dichotomous score items, and we have models for polytomous items. The polytomous is the one you call essay item, or you call it constructed response test, or probably if you have a rating scale, you have a questionnaire, you understand. So, and when you have a ordinal scale of measurement, it also falls within the confine of polytomous. And then when you have this kind of test, there are models designed for each of them. So for polytomous, for dichotomous scored item, we have 4 models. We have the 1-parameter logistic model, we have 2-parameter logistic model, we have 3-parameter logistic model, and we have the 4th parameter logistic model. In our climb here, the first 3 models have been used extensively. You understand? And the 4th one has not really embraced, because it's talking about the carelessness, the response time. You understand? So those are the models for the 1st parameter logistic, for dichotomous scored items. And one of the assumptions of item response theory is dimensionality. Dimensionality is a very important assumption that you must establish to know the number of factors or traits that actually, accounted for the performance of students in that particular test. So if you establish the dimensionality and you find out it's a unidimensional model, then you go for unidimensional models. And these are the models that are called 1-parameter logistic model up to 4th parameter logistic model. And if you establish the dimensionality and you find out that it's more than 1, then it becomes a multidimensional. That is, you have more than 1 trait that accounted for the performance of students in that particular test. Otherwise, you use or you go for a multidimensional model to model the responses of examining in this test. And in that wise, we also have multidimensional 1-parameter logistic model up to multidimensional 4-parameter logistic model. We need to get all these things clear tonight, because I've seen a lot of misconception. People that I've seen a lot of articles written, especially in Nigeria, in this area of test theories, and you find out that researchers, failed to establish some of these things. And they are important. These are the underlying assumptions. There is no way you say you want to do item response theory and you did not establish the assumptions that underline it. And you just go ahead, you say, oh, I use one parameter logistic model or use two parameter logistic model. There must be a rationale for using any of this model. You don't just jump into this this model. And the same thing applicable to polytomous items also. If you can have a polytomous, when you have a polytomous test, it is expected, if you are to use item response theory, to establish the underlying assumptions also. You have to establish the dimension. Is it uni or multi? And we have some models for polytomous tests. We have the graded response model, we have rating scale model, we have nominal scale model, we have partial credit model, we have generalized partial credit model, and so on and so forth. If it is unidimensional, I mean the polytomous. If it is multidimensional, you go for multidimensional graded response model, multidimensional generalized partial credit model, multidimensional partial credit model. And the same thing applicable to the second assumption that underline the use of item response theory, that is the item local independence. The item local dependence, if it is more, if your test is multidimensional, you are expected to establish the item local independence using that multidimensional model. But when you look at some of these publications, articles published in this area, you find that there are a lot of misconceptions, there are lacuna in what they published, and then you will see that the upcoming researchers, the young one in the area of testing and measurement, look up to some of these articles to guide them when they are writing their own. And I want to appreciate the organizer of this webinar and to synthesize researchers in the area of educational assessment and psychometrics to know the nitty-gritty on how to establish some of these things is very important. But this training, this 1 hour or 30 minutes or 2 hours training is not enough, to say, oh, I'm an expert in this area. It's just an eye-opener for you to go back, look for good tests, read extensively, so as to have a better understanding of how some of these things works. So, like I said the other time, we have the responses, and we formatted the responses using the command delimited, which is CSV, and we created a folder on the desktop, and I named that folder IEEE, if you remember. Then tonight, let me call this thing, let me call the what is it called, the responses that you want to use for the analysis. You need to call it and make sure that you import it into our environment. So I said get W, then you open this, you run. So, and then after that, I said you set the work directory, which is work directory. Are we together?
Yes, we are with you.
Okay.
We are with you.
Okay.
We can hear you.
Okay. So put this there, and then I told you the directory where you open, where you created your folder needs to be changed. If it is document, then you leave it in document. If it is desktop, you have to change it to desktop. Like my own now, I created the folder on my desktop, so I need to put it desktop there. And then in the desktop, there was a folder I opened on the desktop named IEEA, like this. So after that, you put your cursor outside and then click on run. So, and then you will see that it has run successfully. Once you see this greater sign, it means that your code has, run successfully. So, and after that, the next thing is to you know, the data we formatted is inside the folder. This folder name.
So, sir, if we don't have that sign, what do we do?
Yeah, if you don't have that sign, it means there is a problem with, for example, now let me do something like this. Let me just put IAE, for example,
Okay.
and then let me run it. Can you see? It will tell
Yes.
you error in set work directory. You understand
Yes.
that? This cannot change working directory. So when you have this kind of error, you will know that there is a problem with the syntax or the code lines. And the beauty of using the R software is that as you are progressing, if your code lines are correct, it will tell you it's correct. If it is wrong, it will bring an error showing that there is a problem in your code line. So then you have to revisit the code line and say, and like I said, it is R is case sensitive, you understand, and then it is important that you look at if you use, for example, now we use IAE like this. So if I change it to small letter, say IAEA, it will run.
Oh, it's case sensitive.
Is that?
It's case sensitive.
Yes, it's case sensitive. So you have to make sure that what you have is in line with what you put IAEA. So when you have this now, then you will run it. So run successfully now. So the next thing, the next code line is to bring the data. You know, the data we formatted is inside the folder named IAEA. So let's read the data. So we now said IQ read dot table. So this is the code line you are going to put if you want to call the data or to import the data. IQ.csv, comma. So you have sep equals this, then comma. You have this. Then we have the header to be true because we have the variable. You know, the first column, if there is, if you name the first row, you have the variable name like item 1, item 2, then your header will be true. But if you don't have, then it will be false. So click on run. So it runs successfully. Now to see our data, then you can say fix, open close bracket IQ. Then you run. So this is the data. And this is one way of doing it. Another way of doing it, you can say add. You can write add IQ. Then you run it also. So this one, it will bring it here. You understand? Or you can write view. But if you want to write the view, the V should be in capital, view IQ. You run. You can see you have it also. It will now display here. You understand? So there are different ways by which you can, you can call your data. Are you with me? So that's that. Now, the next thing, after you've successfully imported your data set into the R environment, then the next thing is, okay, which type of analysis do I want to perform or conduct? Now, we are interested in item response theory analysis. And like I told you, the package that we are going to use is called Latent Trait Model. Latent Trait Model. That is the package that we are going to use. And if you remember, I said we have more than 10,000 packages embedded or inbuilt in the arrayed environment. So you have to call the library after you must have installed the package. And I told you if you want to install the package, you click on Tools, then you come to Install Packages. It's a function of how strong your network is. So, and then you just put it, the latent trade model is, the acronym is LTM, which is this one. So you just click on it, then you click on install. So it will start the installation, but already I've installed it, so there is no need of install it again. So let me cancel it. So now for me, the first thing is to call the package that you want to use for the analysis. Now to call the package, you say library, you write library, open close bracket, then LTM. That is the package you want to use, LTM. So you run it. So you wait for it. So then you can see that it's telling you that this has been installed, and then it was built under R version 4.05. You understand? So it means all this thing is telling you that the package has, installed successfully, and then you can use it because you are calling the what is it called? The package for that particular analysis that you are interested in. And if you don't forget, the last in two weeks ago, for the classical test theory, the package we use is called psychometric. That is the package we use for the art analysis. So, but for item response theory, latent trait model is one of numerous packages that you can use to start to conduct or to perform the item, the calibration. We'll call it calibration. Let me just put it like that. We'll call it calibration. But to a lay person who is not a psychometrician or in the area of educational assessment, you say item analysis. You understand? But for some of us, as an expert, you say once you hear calibration, we know what you are talking about. So there are numerous packages that you can use for this particular purpose. We have latent trait model, we have supplementary item response theory, SROT, we have a multidimensional item response theory. Hello?
Yes, sir, we can hear you.
Yeah, I think someone is raising his hand. I don't know if there is any question before I proceed.
Yes.
You have question?
Yes, I wanted to find out the Latent because I checked my tools now. I couldn't get which of the Latent this thing I'm to install.
No, when you click on the tools, you will see ITM. But what I did was to tell you the full meaning of ITM is called latent trait model. But you will not see latent trait model from the packages there. You understand? What you will see is just write LTM, this one.
Okay.
Have you seen it?
Yes, I've seen like LTM.
Yes. So you click on it like this, then make sure that you check the install dependency, and then you click on install. So it will start the installation for you. But make sure that your internet is strong. And once you download, you download the package, you only need to download the package once. So subsequently, if you want to use it, there is no need of downloading it again. Just for you to just call the package like I did now. Is that taken?
Yes, it's done. It shows me
Okay.
package successfully installed.
Okay, good. That's fine. Now, so the next thing is to begin the analysis. We've imported our data successfully. We've called the library that you want to use, I mean the package for the analysis. And tonight, I'm going to show you using this if time permits us, I'm going to show you using this package how to establish the one parameter logistic model, which is in some context otherwise known as Rash model, the 2-parameter logistic model, and the 3-parameter logistic model, and also to show you how to establish a dimensionality, or let me say model data fit. That is another thing. The model data fit assessment is very important. And this is where you will know which among the models best fit your data, because you must look for model that best fit your data, not the other way around, that your data must fit your model. Is wrong. I've seen some articles written that they say the data must fit the model. No, that has been criticized extensively in the literature. Your model must fit the data. And it's that model that fits the data that you are going to use for your calibration. So I'm going to show you how to establish model data fit assessment, and also the item characteristic curve in terms of item information function, test information function, how to establish the ability. What is the ability? What is the performance of student, each of the students in the test? You understand? After looking at their performance at each of item level. So if time permits us, these are the things I have in mind to put you through tonight. So let's start by looking at the Rash model, which is the first parameter logistic model. And for you to do that, this is the code lines that you are going to write to do that. So let me put it, for clarity's sake, let me name it as IRT Rash. Let me put it as IRT Rash, or if you like, you can put it IRT1PL. And this is not sacrosanct. You are free to name it anything. You understand? Because, you know, I told you about expression and assignment. You are just assigning the code to this. The legal, you can use anything, but for me, I prefer to use what I'm trying to establish, so to be convenient for me to recall that particular thing. So let me say IRT Rash. That is, this one is telling you that you want to establish for what? One parameter logistic model, or you call it a Rash model. It depends. So, and then you now have insert Rash again. So open and close bracket. Now the next thing is the name of the data set that you are working with. What is the name of the data set you are working with? Is IQ. You remember, it's IQ. So you put IQ, then comma, then after that, you have said IRT dot prom like this, and then set true, comma, you have the constraints equals to, then you have column bind. We must do column bind because, you know, for Rash model, is our belief that you are interested in the difficulty of the item alone. just the difficulty of the items, and then our assumption is that the items discriminate equally across the examining. The item discriminate I'm sorry for my network. That's why I even turn off my video. Presently, I'm far away. So where I am is a remote area in Southern Africa. So I went for a research work there. So, and the network here is a little bit more. Can you see my screen?
Yes, we can see it.
Okay.
Yes.
So, and then this you have a plus, then 1, 1. So when you have this is the syntax that you are going to use to run the Rash model, or you call it one parameter logistic model. You understand? So when you have this, so let's click on run. So you can see it ran successfully. It ran successfully. Yeah. So now, after this, the next thing is to see the results. We want to see our results. You understand, in terms of the calibration, or you call it item parameters. Let me use the common one. You said item parameters. Did you get my point? Because for Rash model is interested in difficulty. What is the level of difficulty of the items? And the symbol for difficulty is B. Is known as B, small letter B, like this. Small letter B, that is for difficulty. For discrimination, is small letter A. For pseudo guessing, or you call it chance factor or guessing, so we have small letter C. And for carelessness, response time, and so on and so forth, it depends on how you conceptualize your fault parameters in your model. So that can be represented as small d. So we have small d for that one. So, but for Rash model, we are interested in the difficulty, and that's why we have the column bind, we have the length, and then we have this one. So what we do now is that we restrict, or we constrain our discrimination to be 1, because we assume that the item discriminate equally across board, and that's why we have it. So let's have syntax for the parameters. We have coefficient, then you said IRT Rash, so to bring it, then you have a comma, then what is the probability of getting the items? So we want to see the probability, true. So if you don't want the probability, you can put false, but I mean, I prefer the probability, so because it will have a more robust output. So let's run it and let's see the result. Can you see it? So this is the result. It's as simple as that. You have your result here. So, and you can see the discrimination now is what constraints to be 1 across board. So this one is telling you that the items discriminate equally across the examinee. Now, this is the difficulty, and that's what the Rash model is interested in. How difficult is the item each of the item. Then when you look at this, we have minus 2.47, minus 2. This, and so on and so forth. And look at this is the probability level. And that's why I said, if you are not interested in this probability, just put coefficient this, you understand, IRT Rash, and then you click enter. You press enter, you have your results. And I'm going to show you another way of doing this. So this probability will tell you that for item 1 now, from item 1, you have about 92% of the examining that got it right. You understand? And that's why you see that the difficulty is even negative 0.47. And when you approximate this, you have negative 2.48. So this is one is telling you that the item is of low difficulty, you understand? And this, the implication is that students with low ability level can easily get this item correctly because the item is cheap, you understand? You have negative points. So the same thing applicable to item 2, we have negative 2.56 now, which is approximately negative 2.57. And then when you look at the probability of examining that got the item correctly, you have about 93% of them. So this one is telling you also that the item is very cheap along the continuum. Now let's look at this. We have 0.35. This item, which is question 4, is a bit difficult, you understand? Or let me say moderately difficult compared to question 1, 2, and 3. And when you look at the percentage, about 41% of the examinee got the item correctly. 41% of them, you understand? So this is how to, interpret the result of your output. You look at them, you examine each of the values, the parameters, and then from there, you can judge at the end of the day whether the difficulty is okay or not. In the literature, for difficulty, it's between -infinity to +infinity. But in practice, and according to Baker 2001, 2017, Baker says that -3 to +3 is okay as the level of difficulty of the item. D. Ayala 2010 says -2 to +2 is suffice as the level of difficulty. You understand? But this range of difficulty for the item, depends, is a function of the test information function. When we get there, we explain this. And that's why as an institute, educational, let me say public, for example, like public examining body, you understand? When they are doing their calibration and they want to choose the level of difficulty of the items for their student or candidate, it's not judgmental. There must be a rationale for choosing a particular level of difficulty. You don't just say, okay, I choose -2 to +2. Especially, I'm referring to public examining body now. But if you're a researcher, you can base your level of decision on the level of difficulty based on what other researchers in the literature and the leading experts in this area have been, propounded. But as an examining body, there must be a rationale. If you go to Western world, like educational testing services, when they consult them that, okay, we want you to develop tests for us, blah, 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 and they will ask, you understand, what is the age group? What is your target population, you understand? And at the end of the day, after the analysis, they will tell them, they will now say, okay, for this age group, this particular difficulty level is appropriate for them. You don't just say, okay, yeah. Or probably, for example, now, like if you want to write an NMPC aptitude test, there are a lot of people, they have thousands of applicants, and they want to make sure that the kind of tests that they want to use to assess them, is a little bit of high difficulty in order to, prove the number of applicants to a sizable number. So when they develop this item, they will now say, okay, the level of difficulty will be, let's increase the level of difficulty. And then by the time you increase the level of difficulty, the number of students that will stay through that aptitude test will be very, very minimal because of but all these things is not judgmental. So it has to be scientific. It has to be systematic. And they need to consult an expert to do some of these things for them. So this is the calibration, and then we have our results here as it is. So, and that's all about the one parameter logistic model. Then let's go for the second parameter logistic model. And this, you use this syntax, let's say R2PL, let me put 2PL. Then you have LTM. So what your data is, our data is IQ. Then there is on your keyboard, you will see a symbol like this, by the left-hand side, especially on the tab, your tab key. Before this syntax is between the escape and the tab button. So you see something, I don't know if you see it, or let me do it outside for you to see. You press shift and you see. Did you see something like this? So
yes.
Okay, yeah. Infinix, you raise up your hand. Any question? Kindly unmute yourself and ask your question, please. You raise up your hand, or is it by mistake?
I think it's a mistake.
Okay. So we have, you say IQ, then you put Z1, and I put a comma. You have IRT dot pram, and then you said true, in capital letter. So this is the syntax to use to run for 2PL, and then let's run it. So you can see that it runs successfully. So let's call for, let's see the item parameters, and then, you know, for two parameter logistic model, from the word two parameters, it means the interest is two parameters, that is the discrimination and difficulty. The two parameter is looking at the difficulty of the item, at the same time, the discrimination, that is to what extent the items discriminate between the high ability students and low ability students, or between those that know the material from those that did not. So this is the two parameter logistic model. And then to get the parameters for that, you use coefficient, and then you have IRT2PL, it will bring it out automatically. Then what is the probability? Equals to true. True. So when you have this, then you run it. So we have the results here. This is the results. So you can see we have the difficulty, then we have the discrimination. You understand? And then you look at the difficulty, you have -1 + 5 like that. Then, and when you look at the discrimination now, so we have 2.33, and the benchmark is that for your discrimination, you have greater than 0.2. Your D, what is it called? Your A must be greater than or equal to 0.2. So when you look at this, and then the higher the discrimination, the better information that particular item is given. So when you look at this item 1 now, 2.33 is a very good index, and then this is telling you that this item is what is given better information. And then when you look at the probability of candidates that got the item correctly, we have about 98% of them. And this is also telling you that the item is very cheap at negative 1.5. So the implication is that even those are the low ability, with low ability level can also get this particular item correctly, as well as those with high ability level. So you need to understand the benchmark for each of these, especially if you are just doing a research. You go to, you collect your data and you want to establish the parameters, of the data. So you need to understand some of these things, and this will really help you on how to interpret your results very well. So that is for 2-parameter logistic model. So let's look at 3-parameter logistic model, and the code lines that you are to use. I name it IRT 3PL. IRT 3PL. Put this, so you put the assignment, then you say TPM. You open and close brackets, the data set, which is IQ, you put it there. Then you say type equals, so you open apostrophe. So inside the apostrophe, then you put latent dot traits. Then bring it out, you put comma again, and then you have the IRT.param, which is this, and then put true there. So this is the syntax for 3-parameter, and then you click on run. So that is a problem. It said warning message in TPM IQ type latent dot trait parameter. Asian matrix at convergence is not positive definite. That is unstable solution. Yes. So when you look at this message, you understand? This is just telling you that the data set you are using, the data set is not positive definite. And when you have, when your data is, when the R complain about data not positive definite, so it means that for the engine value, there are, after running a kind of tetrachoric correlation, you understand, it means we have maybe negative value of, you have a 0 as engine value, and that's why the data is not positive definite. But it's just giving us the warning, and then it said unstable solution. But by and large, so far, it does not bring error, because when you have error, it means there is a problem with the syntax, the data point. So the beauty of using this software also is that if the data is having a problem, it's going to tell you that there is a problem with this data at this point, the data point, but there is a way to solve that problem internally, the data point. That is advantage of using this software. So far you didn't see R, it just a warning message. But if you say warning message and then you see error, then there is a problem with the syntax that we wrote. But let's see now if the syntax is okay or not. Let's have the parameter, we have coefficient, and then we have RT 3PL, comma, probability equals true. You see, if there is problem, this syntax, it will not run. It will not run. But it's just telling you here that this is warning message. This is what I observed in the data set. And that is the advantage of this software over other software that's designed for calibration purposes. The R will tell you there is a problem, then, and there is a way we can solve this problem. So, and if the problem is unsolvable, then it will bring error. You will see error. That is a problem. So from here now, our parameters is out, and then these are the parameters. We have the guessing, like I told you, this is the C. You understand? This is the C, and then we have the difficulty, which is B. We have the discrimination, which is A, and this is the probability of getting each of the items correctly. And the benchmark for this one, which is the guessing, is that your C must be less than or equal to 0.35. That is the benchmark. The moment it's above 0.35, then it's not okay. For the purpose of test development, if you are interested in developing a new test, you understand, then you must make sure that all these criteria for guessing, difficulty, and discrimination, that the values, meet the benchmark before this item is good. So if one of these, for example, now, if you say for guessing, it was less than 0.35, and then when you look at this is about 0.000 something, then which is okay, it's less than 0.35. This one, let's assume that we choose from -2 to +2, and we have -1, which is it falls between this range. And then for discrimination, we say it must be greater than 0.2. You understand? So, and then we have 2.2, which is still okay. So if for the purpose of test development, we are just developing a new test, and then you want to choose those items that are okay, then so you can say item 1 is good, then you choose it. So these 3 benchmarks need to be met before you can say the item is this or that. So, ladies and gentlemen, this is how to establish the first parameter, second parameter, and third parameter logistic model. And like I told you, the fourth parameter logistic model, that is another model, but this package does not have the capacity. I mean, the latent model does not have the capacity to establish the 4 parameter logistic model. So it can only establish 1, 2, 3 parameter logistic model. And I know that multiple MIRT, which is a multidimensional item response theory package, it has the capability of establishing the 4th parameter logistic model. But for the purpose of this webinar tonight, we are looking at the first 3 model of a unidimensional model. So now let's look at model data fit assessments. So if we are to look for the best model that fits this data, then which model can we use? Which model that best fits this data? So, and it's called model data fit model data fit assessment. So now to do this, you say we want to hypothesize. Now we want to hypothesize that between the first parameter, we want to hypothesize that there is no significant difference between the first Rash model and 2 parameter logistic model. That there is no significant difference. That's my hypothesis. That's what I want to hypothesize to establish my model data fit assessment. So, and also, I will also hypothesize that there is no significant difference between the 2 parameter logistic model and 3 parameter logistic model. So among these, after my hypothesis, so I need to go for the parsimonious model. The parsimonious model. And what are the things you use when you are looking at model data fit assessment? You look at the -2 log likelihood ratio. You look at AIC, that is the archaic information criterion. You look at BIC, that is Bayesian information criterion. You understand? You look at the chi-square and so on and so forth. You also have sample size Bayesian information criterion, that is SBIC. So these are the things we are going to look at to determine the parsimonious model. So you will look for model with lesser values of AIC, BIC, and so on and so forth. So the lesser one is the parsimonious model. And that model will be the model that you will use to fit your data set. So let's examine that. So we have, this is the function we are going to use. It is called ANOVA. It is called ANOVA. At times in some textbook, they call it comparing model fits. Comparing model fits. But I prefer calling it model data fit assessment. So we use ANOVA, and then now I want to hypothesize that there is no significant difference between the Rash model and two-parameter logistic model, which is 2PL. So we have this, then let's run it. Yes. Someone is writing on my screen. So this is the comparison. And when you look at the p-value here, you will see that it's significant. And when it's significant, the implication is that there is what is it called? There is significant difference between the Rash model and the what do you call it? The two-parameter logistic model, meaning that what will reject the null hypothesis. You understand? So, and then when you reject the null hypothesis, the implication is that there is significant difference between the two of them. So now when you now look at the two, we have AIC, which is archaic information criterion. We have the BIC. We have this is Bayesian information criterion. We have the log likelihood ratio. We have the LRT, which is likelihood ratio test. We have the degree of freedom. We have the p-value. If you are using MRT package, which is multidimensional item response theory package, you have SIBC. And the SIBC is sample size Bayesian information criterion as part of the output you are going to see if you are using that. So now we have for the Rash model, and we have these values. Then for two-parameter logistic model, we have two values. So how do we choose, or how do we say that, okay, this particular model is the one that best fits my data? So you look at the values with lesser value of AIC, BIC, and log likelihood ratio. And like I told you that the lesser value is what is the most parsimonious model. And for some of you, if you are using this common software for calibration, BylogMG, you understand? But BylogMG is designed for a unidimensional model. If your data is not unidimensional and you are using BylogMG to do your calibration, what you are doing is wrong. So if you are using BylogMG and to determine the parsimonious model, after running your one parameter, in fact, if you run the one parameter, two parameter, and three parameter, then you look at -2 log likelihood ratio. So it will give you the iteration, the last iteration, the last cycle. If you are conversant with the software, the output of BylogMG, you will see that the last cycle, you will see the -2 log likelihood ratio, and it will tell you that it converges at you will see the convergence there. So that -2 log likelihood is the value that you are going to extract, and you now compare this -2 log likelihood ratio for each of these model, and then you choose the lesser one will be the parsimonious model that fits your data, and that is for BylogMG. But in our software, the results produced by R is more robust compared to this software that I just mentioned. You see that you have AIC, you have BIC, but for Bylog, we only give you this log likelihood ratio alone. So and then when you look at this, we have 11435.29 for the Rash. And then when you look at this, for 2PL, we have 11258.66. So you see that the value under the 2PL for AIC is lesser than the one under the Rash. Then moving to BIC, which is Bayesian information criterion, you will see that we have 11535.08, and then for 2PL, we have 11458.23. And this also is less than the BIC value for Rash model. The same thing with log.likelihood. You have 5579 here, and this one we have 5692.61, and this one is also less than. So the likelihood ratio test now, because you hypothesize, you understand, it's like it's like a suppression, you understand. So we have this as the LRT, and this is the degree of freedom 25, and the p-value is what telling that it is significant. And when it's significant, you reject the null hypothesis that states that there is no significant difference between the first parameter logistic model and the two parameter logistic model. So based on this now, if you want to choose the parsimonious model now, we'll go for 2PL. That is that the 2PL best fit our data set. Please, infinite note, please, you are writing on my screen. So now, once you've observed that 2PL is most parsimonious now. Now let's hypothesize 2 and 3, that there is no significant difference between 2 and 3, and then let's see what the result will look like. So we have ANOVA open, then you have IRT 2PL, comma IRT 3PL. So let's run it. And you have the result. When you look at this result, now, when you look at these results now, so you hypothesize 2PL and 3PL. So the 2PL now has this AIC value, BIC, and all that. And then 3PL. Hello?
Hello, we can hear you now.
Yes. I said, who can tell me the parsimonious model between 2PL and 3PL based on these results and my earlier explanation?
It will be the 3PL.
Okay, what is your reason? Why is it 3PL?
Because it is lesser than the 2PL. The AIC and the BIC are less than the 2PL.
So are you sure they are lesser? Look at it
Yes.
very well.
Okay, the
3PL is significant.
The 2PL is lesser than the 3PL.
Why?
Because if you look at the AIC, you have 1125, and then you have what they wrote here. I'm not seeing this value very well.
And that's what
Yeah,
I'm
it's
saying.
right
The
up on
person
the
that is
screen.
writing on my screen, I don't know.
But if you look at the second one, which is the BIC, you notice that the value 11458 is lesser than 11450. But for the third one, for logistic, like mathematical, is higher here.
Yes,
Can't
thank
believe.
you very much for
I
your
don't know.
observation. Yes, now
Yeah.
if I'm to conclude from these results, I would say the 2PL is the most parsimonious model that fits
Okay.
this
Yeah.
data best.
Yeah.
And the reason is this. When you look at the AIC for 3PL, you will see that it's actually lesser than the AIC for 2PL, which is
Yes.
fine. Then look at BIC. BIC for 2PL is lesser than 3PL, BIC for 3PL.
Yeah.
And when you look at the log likelihood also, you will see that the 3PL is actually lesser than that of what is it called? The 2PL. But why 3PL is not appropriate is because the three values, or let me say the three indicators that we are using to determine the most parsimonious model, the BIC is greater than that of the 2PL, which is not supposed to be. So automatically you go for 2PL, you understand? And that is the reason for choosing the 2PL as the parsimonious model. In my experience as a data analyst, I've seen candidates, PhD students, based on what I've, what I've gotten from my clients, let me just put it like that. They will just tell you that, oh, we want 3PL. I will ask them, why 3PL? They will say that my supervisor said it must be 3PL, that I should establish the 3PL. You understand? Please, who is writing on my screen like this? So they will say, my supervisor said I should use 3PL. I will ask why the choice of 3PL? They will say it's my supervisor that said 3PL. I said, why can't you ask your supervisor why the choice of 3PL? But because they believe that they must establish the three parameters. And it's not so. There must be a rationale before choosing any of this model. In fact, you will see some tests that is 1PL that will be the best model. And at times, I've seen some research work, and the people will just say, I'm comparing, I'm looking at a 1PL for this test. And at the end of the day, they will say, oh, this test is too difficult. Why the choice of 1PL? You've not established the model that best fits the data that you are working with. And at the end of the day, you said, using the Rash model, then the test is difficult. That is a wrong conclusion. And that's why I said we need to understand the nitty-gritty behind some of these things. You don't just feel that, okay, I want to write a paper, and then you just feel like, okay, let me just use 2-parameter logistic model for this, and then let me do the calibration, let me run the descriptive statistics, then I will say the item discriminates equally among the examinates, or the level of difficulty is moderate, or is high, or is low. All these things, they are fallacy, because they did not pass through or follow the best practices. And these are the things the young researcher, the upcoming researcher in the area of educational assessment, they will look at some of these write-up as a guide. So the mistake made by them, it now be a generational mistake. And that's why I do tell my clients, when you come to me for analysis, there are so many things at times when they raise research questions in this area, I'll tell them all these things is not researchable. And they will say, oh, my supervisor approved it. But at times, as a data analyst, when you advise your client, if he or she insisted that this is what my supervisor said I should go and do, then you have no option. You just have to oblige and do the work the way it is, and then you just give it. But you know that this thing is wrong. And at the end of the day, this is what they will start publishing. They will go to conferences, they will start presenting, and so on and so forth. So if we fail to have the rudiments of some of these things, then we'll continue to make a lot of generational mistakes. So this is how to establish the model data fit assessment. If you have the 4-parameter logistic model also, this is the same way. So you have to hypothesize that you hypothesize there is no significant difference between the 3-parameter and the 4-parameter logistic model. Then you look at the indices to pick the one or the parsimonious model among these models. So now that we know that the best model is 2PL, so we'll be working with 2PL with other things that we are going to establish. So let's okay, before that, let me establish the item fit for the 2PL item fit. This is another way that you can. Hello.
Yes, there is a question on the chat. I think it's good you answer that question before you continue.
Okay.
Yes.
Let me check. Please, can you re-explain the choice, the reason for the choice of the 2PL relative to the 3PL? Thank you. Does it imply BIC takes precedence over AIC when choosing the best model? Okay, thank you very much for those questions. Well, one is not superior over other. Let me just put it like that. But before you can say the 3PL is appropriate, then it means that all the values here, you understand, must be lesser than the 2PL. And already when you hypothesize, you know, we hypothesized 1PL and 2PL earlier. And when you look at the indices, the values for AIC, BIC, minus log likelihood, you will see that they are actually, you know, lesser than the Rash model. And that's why at this point, we said 2PL is parsimonious. Now we move ahead and forward, and then we say we hypothesize 2 and 3PL. And 3PL for AIC actually is lesser, but when you get to BIC, it's greater. Then when you go to log.likelihood is lesser also. But because this one is greater, you cannot say that 3PL is appropriate. You cannot. But if all for AIC, BIC, log likelihood is okay, which is lesser than this, then you can say the 3PL is parsimonious. Is that taken? Is that taken?
Yes, sir.
Okay. So another method that you can use, if, for example, now if you are using IRT Pro, if you are using IRT Pro will give you diagnostic statistics, that is the item fit. So you can use the item fit also to determine the model data fit assessment. So you will run for 1PL, 2PL, 3PL. Then you look at the number of items, items that is non-significant. For example, now let's say for 1PL, when you, after running the analysis, you now have, let's say out of 25, you have 10 items that survive. Then you run for 2PL, let's say 20 items survive. You run for 3PL, let's say 15 items survive. So automatically the best model is the one with highest number of survived items with item fit, and that is the 2PL. So let me show you how to do that in R also. So we have item, just say item.fit, and then you have for 2PL, IRT 2PL. Let's wait. It's running. Yes, the result is out. So when you look at this now, you will see this is the chi-square and this is the probability. Then before you can say the item fits this particular model, then it must not be significant. Once it's significant, that is less than 0.05, that item is not fit. For example, now looking at this item 1 now, this is 0.0081, which is less than 0.05, so it's not fit. This is 0.004, it's not fit. It's 0.14, this is fit, which is item 4. I mean, item 3, rather, is 0.14 is greater than, you understand? So the items must not be significant. I mean, the probability, rather, it must not be significant. So this is how to establish the fit on, what is it called? On R. So if you want to, if it is 1 PL, or let me say 3 PL, just put 3 PL and let's see. It will also run. Then you add this for 3 PL. Can you see it? So use the Rash, you run for Rash also. So at the end of the day, now the one with highest number of items, you understand, with not significant, then that model will be the parsimonious model that you will choose. Now, ladies and gentlemen, let's plot a graph. You know, we have, what is it called? Item characteristic curve, or you call it item response function, whereby, and that is in some tests, it is called monotonicity assumption of item response theory. And it's trying to establish the probability of examiner responding correctly to item based on their underlying ability. So there must be a relationship, you understand? And as the ability increases, then it is expected that the probability of getting the item correct also increases. And if it is otherwise, then there is a problem with the discrimination or the difficulty. So let's quickly look at that. So let's say we have plots. We want to plot the graph. So you say plot. Since 2PL is the most parsimonious, let's plot for 2PL. Then you say type equals, and what to plot ICC, which is item characteristic of, or you call it item response function. Then you click. Can you see it? So this item characteristic of for all the items in the test. You understand? And you will see that at this point now, this is what at the lower level. This is lower asymptotic. This is lower asymptotic, you will see. And then when it goes up and then to this place, this is the high ability level. You understand? This is high ability level. So when you look at some of these things now, look at question 22, question 22 and question 21. You will see that at high ability level, still the probability of getting the item correctly is very, very low. You understand? When you look at the line, it's very, very low. It's very, very low. And then for like item 9 now, this is item 9, you understand? So the probability, the ability required to get this item correctly also is low, because it falls around maybe minus 1 or so. You understand? So the probability of getting this item also to get it correctly is very low. This is the probability of getting the item correctly. This is the ability and the location, the item location. They are on the same continuous. You understand? Both at times they call it difficulty. You understand? And then the ability also. So as the ability increases, so there is tendency of getting the items correctly based on this, and this is the item characteristic curve. So if you are interested in getting each of the item characteristic curve, this is the entire ICC for the test. So you just say plot IRC 2PL 2PL, comma, you have type equals to, okay, type, then you open the apostrophe, set ICC, then it now depends on the item. For example, now, if I want to plot item 1 now, the part, I will just say item equals to 1. That is, this one is telling you that you want to plot item 1. So you click on OK. So it will give you, this is for item 1. This item characteristic of for item 1. And when you look at this now, you will see that the probability of getting this correctly now is like, it's almost like a moderate ability. See, let's say something around this. Okay, no, let's say this. So it's even low ability level. So you have something like this. If you want the another, let's say item 6, you see, and you see that even this one does not even provide much information. So you can do as many as possible if you're interested in checking them one after the other. So this item 25, so that's how to do that. Then let's look at test information functions. Then you say plot equals IRT 2PL, comma, type equals IC, comma, item equals to 0. So this test information function, and the test information function is contribution of all the items in the test. You know, we have item information function. That's the one we do the other time. So the information, the sum when you add all the items information, so it will give you test information function. And for this particular test now, the maximum information now is around 6 point something at what range ability. So the ability, let's say, is around, let's say, -1. You understand? So the maximum information for this test is around 6.1 at ability level of -1. Did you get my point? So another thing that you look at is that this thing, is it normally distributed or it is skewed? And when you look at this one, you see that it is skewed. It's a skewed curve, as you see it. This is a skewed curve, and then it's skewed towards the right hand side. And then you see that when you look at this, this is telling you that the examiner with low ability level actually, you know, perform better in this test. You know, see, it peaks at this place. So when you have this down, you will see that here now, and as it is going, it's descending. Did you get my point? So you cannot say that this is a normal distribution curve. If it is normal distributed, you understand, then if it is normal distribution curve, then you have this, it will peak at 0. You understand? Telling you that both the low ability level, then as it's rising, it gets to this place, then also descending, and then it gets to what? To high ability level. But this one now is positively skewed, and then it's telling you that those examinees with low ability level actually perform better. Now, if these tests, maybe as a public examining body, they want to use this test, you know, and they want to decide the level of difficulty. So if they want to decide the level of difficulty, then they will come here now. At this point, they will just trace it down. You understand? They will trace it down here, and also here they will trace it down. So in between here and this place will be the appropriate level of difficulty for that particular test. And that's why I said, if you are just You are just a researcher, you are developing a test of that or what have you. You can make reference to what others have, propounded or suggested in the literature, -2 to +2, -4 to +4, -3 to +3. But if actually you are developing, as a public examining body, you are developing a test, then it is expected that you use test information function also to determine this. And then the test information function is talking about the precision of that test. What is the precision? You understand? That is the essence of test information function. How precise is the test? When you are talking of classical test theory, we talk of reliability. You understand? So in item response theory also, this is our reliability, because the reliability is talking about the precision, you understand, over time. You are talking of internal consistency of those items and how precise is some of these items in predicting the performance of students in that particular test. So ladies and gentlemen, this is where I'm going to stop. And I think you've learned one or two things from this. So I will advise you leverage on this and then you amplify on how to do the analysis. And with practice, they say practice makes perfection. You can become a wizard. As I'm talking to you also, I'm still practicing on how to use this software, but there are some challenges that comes to my way that I need to sit down, write the codes and make sure that the codes works for that particular analysis. And if I can learn some of these things, I believe you can also. I'm not a programmer, I'm not a computer scientist, but it's all about zeal and passion. So when you develop zeal and passion this year, I believe it's something you can learn and you can become a wizard and also as an expert as a data analyst. Thank you very much for your time. God bless you.
Thank you very much, Dr. Anyawali. We enjoyed the lecture. Please, let's go to the chat. Is there anybody who have a question? You can please drop your question on the box, on the chat box. Then you can just take their question from the chat box. But if there's no question, if there's anyone that wants to ask question, you can use the button, raise of hand, so that it will be called. Okay, it's like there is no question from the chat box. Do we have anyone who have any question to ask? Please, you have the floor. Can we say that the absence of a question means that we did not follow our, okay, there are some hands now that is being raised. So we follow that order. Infinite no time. Please, next time, call me with your name. We will not call you next time if you come like this. So please tell us your name, your institution, and where you are coming from. You can unmute yourself and speak to us. Infinite no time.
Hello, sir.
Good evening.
Good evening, sir. Adepoju from Nigeria. Emmanuel in the College of Education. I want to find out, sir. Somehow you will use research questions, and at times we use hypothesis. Which is better for IRT model? Thank you, sir.
Okay, over to our guest lecturer. Yes.
Yeah, well, for me, so far the questions are not, let me say, tautology, because I've seen a lot. You see, people who raise research questions you put question in under the research question and at the same time in the hypothesis, it's the same question they will ask. For example, if you say, is there any significant difference between performance of male and female students? You understand? That is a research question. And they will still go ahead and then say research hypothesis. They will say there is no significant difference between the performance of, you are saying the same thing.
I'm really very sorry.
So you need to stick with one. So for me, for item response theory, it depends on what you want to achieve. For example, now, if you are working on differential item functioning or measurement invariance, you understand? It depends how you can raise your question as a hypothesis, you can raise it as a research question, you understand? You are using the same approach to analyze the data. So use the one that you feel that you are most comfortable with. But the problem we have in Nigeria is that the postgraduate college, they have their policy. There are some schools that will say you must have both research questions and research hypothesis in your work. You understand? For example, like University of Ibadan, it's not sacrosanct. You can have
the names were not out as I last time I read.
You understand? You can have research questions all through your work without research hypothesis. And if you so desire that you want to have the two, nobody will penalize you for that. And I think because of that policy, that's why most candidates usually include, or let me say, repeat the same thing they have under the research questions in the research hypothesis also. But for me, you are free to use any of the two, so far you are comfortable with it.
Thank you very much.
Thank you, sir. Thank you, sir.
Yes, the next person we have Yagima Pala. Please introduce yourself. Tell us whether you're a doctor or and which institution are you from?
Evening, Dr. Musa. My name is Kyama Bala, as you can see there, from Nasarawa State University in Nigeria. I want to take us back a little bit, like the CTT we did the other day. Two variables were not there, like the validity and criterion reference. This thing were not part of what we did last week, and I was thinking that we'll go back to that, but that notwithstanding, just like you said at the end of the lecture, that one can also try it on his own to see if he can actually get that. Then the second aspect is the IRT and the CTT. Now, which one is which one would be more appropriate for a researcher who used both research questions and the hypothesis? Thank you.
You can go ahead, Doctor.
Okay. Well, let me start from the last question. If I understand your question very well, sir, you said for classical test theory and item response theory, that which one is most appropriate for research questions or research hypothesis. I don't know if I get the question right. Is that so?
Yeah.
Okay. Well, the two, they are theories used in educational assessment, both the classical test theory and the item response theory. And there is no way you talk of item response theory, then you will not talk of classical test theory, because that is the genesis. So in your work, you can use the two, and that's why I said it depends on what you want to achieve. you can use the two, both the classical test theory and item response theory. And if you so desire that, okay, since item response theory has been established as a better framework, then I will go for item response theory, and then you raise your research question or research hypothesis based on the theory that you used in your study. And the first question, I don't know, you talk of validity, criterion, predictive, I don't understand, but my own understanding of some of this validity, we have different types of validity, and then consider you have face validity, content validity, criterion validity, or construct validity. These are the validity that I know. And as test and measurement expert, especially when you are doing scale development, you need to establish the validity of your instrument. And at the same time, even if it is a test, you need to establish the validity of that instrument and let people know that, okay, this is the valid. So, and you can use content validity index, which propounded by Logistic validity index. So you establish the content validity ratio, and then you have the CVR, and then from there you can have by sending your questions to panelists to look at the essentiality and non-essentiality of some of these items, and then you calculate it. At the end of the day, you have your CVR. And if you are talking of predictive validity, I think predictive is more or less like, you know, is future. You understand? You are using a particular test to predict. For example, now you have mock exam, and then you use mock exam, students' scores in mock exam to predict probably their results in the external exam. That if you are able to pass, provided that mock exam is it has the same standard with that of maybe WIC or NECO or what have you, and then you can predict that, oh, for you to get score 80 in this mock, then you are expected to perform. So it's more predictive, and then to establish that, you just use a correlation to establish a predictive. If there is high correlation, then you can say that the mock exam predicts others. And if this criterion validity, you know, we have two types. We have predictive, and then yes, you have predictive and the concurrent validity. So you develop, I've talked about the predictive, but for concurrent validity, then you have an existing instrument, you develop one, and then you want to see whether the two instruments can be used concurrently, simultaneously, interchangeably, you understand, in terms of scores. So then you correlate the two, and then if there is high correlation also, then you can say that you have a concurrent validity. And I think some of this is something that you can, you know, establish on your own.
You are muted, sir. We can't hear you anymore.
Oh, I don't know who muted me. But can you hear me now?
Yes, we can hear you now.
Oh, okay, okay. So I'm saying that the validity is not really applicable in this theory that you are talking about. You are interested in the parameters in terms of the difficulty, discrimination, and so on and so forth. And for validity, you can establish that using different approach, that either to predictive or concurrent validity or criterion or what have you. Thank you.
Thank you very much. Let's have the last question for tonight. Dr. Amina Tegerumbi, you can unmute yourself. Amina Tegerumbi, you can unmute yourself and ask your question, please.
Yes, good evening, sir. Good evening, everyone in the house.
Good evening.
Dr. Musa, thank you so much.
Thank you.
My question is, the AIC same as Z residual in when you use
Hello? I think we've lost her.
Maybe her network has gone back.
Okay. I think with this, it's already almost 10 o'clock in Nigeria. I think with this, we can draw a curtain, and we are very, very grateful to our lecturer. And I believe as he has advised us, it may look to some of us as if he's speaking a language we don't understand, but with much practice, we'll be able to get there. So can we give a round of applause to Dr. Anyowali for the good work he has done? Whether
Thank
you
you
can
very
hear my
much.
own clapping. Thank you very much. We are very grateful.
Thank you
Before
for
we draw
inviting me.
the curtain, I want to announce to the House that our annual conference is going to take place from October 17 to 21st. Please, let's write it down. And it's going to be hybrid in the sense that it's going to be both virtual and physical. And the venue is NAPTEP, Nigeria. NAPTEP is an assessment body in Nigeria. So they are going to co-host the IAIA conference. So let's give it a wide publicity. If you are already in the WhatsApp platform of the association, you will be seeing the flyer very soon. If you are not in the association platform, please, and you want to join the platform, please just send your name, your institution, and your phone number to the chat. Then we add you to the WhatsApp so that you will be able to have access to information that will be going on. On this note, I want to appreciate all of us again for coming. This has been a wonderful time. Assessment is a wide area. And when we started talking about item analysis, we've been talking about item analysis. I think this will be our fourth contact now. And from Dr. Ayonwale, you see that it's not that we have been able to become, we have not yet an expert. So we need to continue to develop ourselves. And I believe that one of these days we shall get there in Jesus' name. I also want to say that we have an objective, and the objective of the association is innovation, to do things better than the way it has been done. So I believe that one of these days we are going to have, apart from having annual conference, we are going to have a think tank meeting whereby we want to apply all this knowledge we have been gaining from our webinar presentation to be able to make Africa the best continent in the whole world. I believe we can get there, the grace of God. On this note, I want to call on Folusho Arowojolu to say the closing prayer for us. Over to you, Folusho Arowojolu. Can you pray for us? I think you already unmute yourself. Okay, let's go to Ghana then. And we have Betty Nalinga.
Okay, Father, in Jesus,
amen.
We appreciate you for this evening, for all that you have done. Thank you even the lecture for us this evening. Thank you for the knowledge you have gained. Father, accept our thanks in Jesus' name.
Amen.
Lord, all that we have learned today, we ask that help us even to be able to use it when we need it in the name of Jesus. And help us even to impart even others in Jesus' name. In Jesus' mighty name we have prayed.
Amen. We are very grateful for your coming. All the way from Ghana, we thank you, Betty. All the way from Uganda, I think your own time will be around 12 midnight. And you are still with us, Dr. David One. We appreciate you. Dr. James Uba, you are very welcome. Sam Mubarak, we are grateful for your coming. Bala from Nasarawa State, you are very welcome. And our guest lecturer, Dr. Adekunle Ayonwale, despite that you are in a remote environment, you still create time to share knowledge. Say that God continue to bless you. So thank you, Patient Lange. Physical Salam, we are very grateful for coming. Robert Osman, you are welcome. Ruth Anna, you are welcome. Sesoma Pekuje, I'm sorry for not pronouncing the name very well. You are very welcome. Simon Alansan, welcome. Taiwo Ganiyu, and many other people that were with us tonight. Olusho Aru Jolu, you are very welcome. Hope to see you, and I want to see you presenting paper during our forthcoming annual conference. Let me announce the date again. It's 17th October to 21st of October, and it will be coming up live in the NAPTEP complex, number 1 Ikuba Hill, Benin City, here in Nigeria. So let's begin to spread the news and to get our papers ready. Already on the WhatsApp platform, the team and the sub-team are already there. So let's use the avenue to get our paper ready for writing and for presentation. Thank you very much. I wish you a happy night rest and good night.
Thank you. Good night too.
Oh, sorry, Dr. Ajibade Victor, you are very welcome. Thank you for coming tonight. God bless you. You have been regular and you came very early. Thank you for coming. Hello, Dr. Ruth Annan. Can you please introduce yourself? You are from where? Which part of Africa? You are welcome. What was Simon Alassane? It's like God doing Clave. You are just coming in. Can we know you, please? Yes. Dr. Simon Alassane, can you introduce yourself? You are from which side of the continent? You can unmute yourself. Thank you for staying through to this time. Yes, we are not hearing you, but you have unmuted yourself. Maybe you should increase your volume.
Hello, can you hear me now?
Yes, I can hear you now. Yes.
Yes, I said Idris Alas and Simon. I'm speaking from Ghana, and I
Okay.
work at University for Development Studies.
Okay.
Yes.
You are very welcome.
Thank
It's
you.
like you are coming. Are you coming for the first time tonight?
No, I was part of the last one we had last month.
Okay.
Yeah, I registered, and but I'm not on the platform you talked about.
Okay,
So how do I get on?
Okay,
the
can
WhatsApp
you
platform?
take down this number? Then you now send your name and your WhatsApp number to this number that I'm going to call now.
Okay.
+234.
+234.
Yes. 803.
803.
42.
803.
42. 92.
Another 42 or?
No, 92.
92.
92 again. Another 92.
92.
4. Can you call it?
Yes, +234. Are you with me? Hello?
I'm with you. Yes, I'm with you.
803 42
Yes.
92
Yes.
92
Yes.
4.
Yes. Yes, you got it. So send your own WhatsApp number and your name and your institution. Then we add you to the platform.
Thank you, sir. I'll do that.
Do you know Professor Kafui Ese?
He's my professor.
Do you know Professor Kafui Ese that is in University of Cape Coast?
Yes, he taught me at the MPhil and the PhD level. So he's my professor. He's my supervisor as well.
Oh, that is great. So
It's
please.
It's our daddy.
Okay.
Yeah, thank
Please,
you.
extend our gratitude to him. He has been very, very good to the association.
Okay, thank you.
We hope that you will also spread the news of the association in Ghana, and you bring in many people to our forthcoming conference in October. So spread the news so that many people will be able to attend by the grace of
Sure,
God.
I'm already doing that. This particular session, I gave the notice to my students, who I believe some of them would have participated today.
Okay.
Yeah, so
okay.
I have about 10 measurement students who are in the MPhil class. So thank you. We'll link up and then we'll spread the measurement news and gossip.
Oh.
Thank you.
Okay. Yeah. You're welcome.
Thank you.
Thank you very much.
Good night.
My friend, Godwin Clavi. Okay, good night. Godwin Clavi. You unmute yourself. Okay, you already unmuted himself. Can you introduce yourself? Godwin Clavi.
Clavi.
Maybe he has gone. Godwin Clavi. Okay. Let Ruth talk to us then. Ruth, can you introduce yourself? Tell us your title, your name, and your institution. Ruth.
I'm Ruth from UCC.
Huh? Increase your volume, please. Hello, Madam Ruth. Can you increase the volume so that we can hear you clearly? Introduce yourself.
I'm Dr. Ruth Annenbrew.
Okay.
Lecturer in measurement and evaluation at the UCC in the Department of Education and Psychology.
Okay. In Ghana too?
Yeah, in Ghana.
Are you from Ghana or from Nigeria?
Ghana, University of Cape Coast.
Hello?
Hello.
Which
Ghana,
part of
University,
Africa are you from?
University of Cape Coast.
Okay, that is Ghana.
Yes, please.
Yes, you are very welcome. You are welcome.
Thank you.
Okay, can we also have Moses Yako to introduce himself? Moses Yako. Moses Yako. Moses Yako. Okay. So thank you very much. What of my friend Bello Masu? Introduce yourself. I've been saying you are very active in our WhatsApp platform. Thank you for that. But introduce yourself since you are still with us after 10 p.m.
Okay, good evening, sir. Hello, good evening.
Okay. Hello, you are welcome.
Good evening, sir. Thank you very much, sir.
Good
I'm from
evening.
Sokoto State, Nigeria. I have
Okay,
MA
that's great.
Management and Evaluation from University Technology, Malaysia.
Okay.
Yes, sir.
You are welcome.
Thank you very much.
So please help us spread the news of our forthcoming annual conference. It's coming up in October. Annual conference.
Yeah.
Spread the news.
Okay,
To the
no problem.
northern part of Nigeria, so that many
We'll
people
do
will
that,
come
sir.
to Benin.
We will do that, sir, by God's grace.
Okay, you are welcome.
Thank you very much, sir.
Okay. Finally, my friend, Dr. Ajayi Timothy. Good evening, sir. Ekaleo. Our friend, they don't understand Yoruba. Better you speak English, they understand.
I think okay, people are still on the platform.
Many are still there.
Yeah, good evening.
Good evening, sir.
Yeah, okay, that's all right. Yeah, that's all right. We thank God for tonight again.
Thank God.
It has been very wonderful.
Thank God.
The Lord will keep us moving.
Amen.
And this year will be better. In fact, it's going to be the best of all. We will make publicity. We invite people. And,
okay.
By the grace of God, we also participate virtually.
Amen. And Benin is very close to our people in the southwest now, or south.
All right.
So, since we are moving from north of Nigeria to south now.
That's all right.
But you can still make their choice whether they want to be there physically or they want to join virtually. Both of them are acceptable.
All right.
Thank you, sir. My regard to the families. God bless
Thank
you.
you.
Okay. Okay, sir. I say good night to everybody, and I wish us a wonderful Sunday service tomorrow morning. God bless you all. Thank you. Thank you. Thank you for coming.
Thank you.
Yeah.